My name is James Potter. I'm a graduate student at Georgia Tech, and this is my entry for the 2013 MATLAB and Simulink Student Design Challenge. A helicopter can pick up and carry loads attached by a suspension cable. This technique is extremely useful for construction, forestry, human rescue, and emergency supply transport operations. Unfortunately, the load swings, which affects control of the helicopter and makes it difficult to safely deposit the load in a desired location, especially if there are obstacles nearby. To study the dynamics of this load swing problem and investigate control techniques to reduce it, our lab needed an experimental test bed. We purchased a remote-controlled helicopter and built a special harness to allow it to be safely flown indoors. For this helicopter system to be useful, we need to be able to measure its position, pitch angle, and load swing angle. We also need to send signals from a computer through the transmitter to the helicopter. These functions are accomplished through an Arduino Uno microcontroller board, which is programmed from MATLAB using the Arduino I/O package, available for free on the MathWorks file exchange server. Another focus of my project is how helicopter pilots, and humans in general, attempt to control systems that have flexibility. The traditional way to study manual control is with tracking experiments, where the human uses a joystick to make a cursor follow a randomly moving target. One problem with the basic tracking experiment is that it's fairly tedious and the human tends to lose interest quickly. So to improve the quality of results, we used MATLAB and the Control System Toolbox to create an arcade-style video game that's based on the classical manual tracking experiments. So far, we've used MATLAB to get experimental data from a helicopter system and a human controller. The next step is to capture their dynamic behavior using MATLAB's System Identification Toolbox. After setting up the helicopter's equations of motion, MATLAB's nonlinear gray box modeling function is used to estimate the unknown parameters. To capture the human's control behavior, MATLAB's process estimation function is used. These dynamic models are combined into one Simulink model. This allows the simulated helicopter to be flown by a virtual pilot. MATLAB can also be used to produce animations that can help visualize these simulations. In summary, I've used a variety of MATLAB and Simulink features to carry out much of my research, and have found the software to be both powerful and user-friendly.